This is my solution to Pommel Quarter's Pico W series, lesson 97, the baby step for the servo signal timing on the PIO. Before I begin, I have to thank Paul for pointing me in the right direction for an issue I had. When I completed the program and tested it, everything was working fine with the servo hooked up as Paul had it hooked up in the video. However, when I tried to hook up my webcam to record my video and started the program, my Raspberry Pi blew up. Turned out the issue was that my Raspberry Pi cannot handle power-wise both the servo and the webcam at the same time. So I really have to thank Paul for pointing me in that direction to solve my issue. So let's get on with it. On the left, you'll see my servo with the arm pointing at 0 degrees. It's on a separate board. You can see my Raspberry Pi kind of in the background. I'll show you. I'll lift this up, and the Raspberry Pi board is back there. But I have another board here on the board with the servo, and it's a power board. If you watched the Arduino lesson 45 last week, which for some reason is missing right now, Paul, for the DC motor, introduced an auxiliary power board you had to use to supply power for the motor. And I remember following the Arduino lessons a long time ago when he used the Elegoo kit, E-L-E-G-O-O, having a similar power board. So I dusted off some old components from way back and found my power board, and that's what that is plugged in. I'm going to reach down here, and this red wire here is connected to the power board at 5 volts. It was connected to the breadboard holding the picow, pin 40, which is where 5 volts was coming from. The black wire here is plugged into ground on that board, and we have to connect it to the ground over on the pico board. Other than that, the orange wire is connected to pin 22. I used 22 instead of 21. So let's go on down with the program now. The PIO program gets 2 inputs supplied by the Python program, and they're passed in via the FIFO TX the period minus the pulse width in microseconds, and the pulse width in microseconds. And this is cheating in a way to avoid having to do the arithmetic to compute one of the numbers. So you'll notice we're using side set. So the program begins by pulling in the period minus the pulse width and copying it to the ISR register. Pulls in the pulse width in microseconds and leaves it in the OSR register. Then we enter the code that is going to do the pulse and move the servo. So the first part is going to copy the pulse width count in microseconds into the X register, and then just decrement that number of times branching to itself. And actually that number of times plus 1, because the last jump when X is 0 won't jump but will drop through. You'll notice the use of side set here. When the X register was set to the pulse width value, it also set that pin high that's controlling the servo. Now, I got this idea from an example that's shown in the RP2040 datasheet. So after this loop ends, it immediately sets X to the value in the ISR, and that's the period minus the pulse width, and also automatically setting the pulse down now. So we'll be running for the rest of the period at 0, and then another similar loop. That's it. Here's the equation of the line that Paul derived in the video. I copied it here just for documentation. I wrote a little subroutine that does that computation because my program will be able to pass in any kind of an angle here. Here's this state machine. You'll notice I'm using a frequency of 1,000,000. That means each instruction cycle is 1,000,000th of a second, and that just so happens to coincide with the microseconds for the pulse width. The side set pin is 22. So now we begin the Python part. We get an angle, and if the angle is -1, we get out of the loop. We get pulse width, calling this subroutine. Print it out just for fun. We do a restart of the state machine. Now this is a new thing. Why do we do that? We can't just activate it and deactivate it and then turn around and activate it again, because it'll activate again at the place it dropped off. We need it to go back to the beginning so that it'll read in the two new values. So after we see that, let's run the program and see what happens. You'll notice that the arm is currently at the 0 position. So I'm going to enter 45. Arm jumps up to 45. I'm going to enter 90. Have to wait. There we go. 90. That was our marveling at the servo arm moving. 90. Gets to 90. We'll marvel a little bit more. 135. Goes to 135. 180. Goes to 180. Let's go back to 45. And finally back to 0. And we're done. Whew, that was a mess, wasn't it? That bit about the external power. So be careful about that if you're using a Raspberry Pi. And again, thanks very much to Paul. Thanks for watching.